Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Mayfield. In this video, again, we are working through this wonderful functions study guide, and we're on page number 7 now. And so we're making sure that we can, first off, hear me to make sure that we can follow those instructions, and you want to make sure that you are reading through these examples, some things to know, and some hints slash facts. So it says, we will be able to determine the independent and dependent variable given a practical situation modeled by a linear function. And so anytime we are working with these values, it says the independent value is usually going to be the x value, and our dependent variable is going to be the output, meaning the y value. And so again, also make sure you have these other labels for yourself. Again, that horizontal, we have that vertical axis. And so, for example, when you run, your heart rate increases. And so, which came first? The running, which is independent variable, and then your dependent variable is your heart rate. So if you are not running or you're resting, your heart rate is going to be lower. So again, just like cause and effect, you have the cause is going to be your independent variable, and then the effect is going to be the dependent variable. So again, just make sure you are reading carefully on these topics. So on the first one, it says Joshua is playing a video game. The more time Joshua spends on the game, the more levels of the game he passes. Which of these is the independent variable in this situation? So it's saying this, it says the more levels he passes depends on how much time he spends on the game. So this is going to be like this. I'm going to highlight my independent variable for this one in blue. So independent variable is the time that Joshua plays. Again, you want to always make sure that this is the one, the independent variable is the one that is measured, where the dependent variable is the result, meaning the more levels passed. For number 2, it says which two scenarios correctly identify the dependent variable. So we're looking for now a dependent variable. So for that first one, it says Maria and Calvin have a business designing websites for small businesses. The more business they work with, the greater their earnings. And it says the dependent variable is the amount of their earnings. Well, and that would make sense because if they have less businesses they work with, the less they are going to make. So their earnings depend on the number of people they work with. And so that makes sense for that one. So we would pick that first one. However, for the second one, we know that it would be the measured amount. So since it says the amount of sugar he eats, again, since that sugar is measured, it would not be what we're looking for. So we're looking for mainly just that dependent. So it's not going to be that one. For the third, same idea. It says a construction manager notices that the longer a project takes to complete, the higher the cost. And so again, length of time, that's not going to be dependent. It would, for that situation, it would be the labor cost. And so that means the last one has to be it. And so we can find where it is. It says the greater number of hours of daylight in a day, the more time Roger spends on the yard work. So that means, yes, the dependent variable is working in the yard. So again, the amount of time that Roger works in the yard depends on the daylight. So you're not going to work out in the dark, as it is difficult to do that. So keeping that same idea, it says for number 3, Mr. Roberts hired an electrician to work on his home. The cost of electricity was $30 for the service call, plus $35 for each hour's work each. Identify the independent and dependent variables in this situation. Making sure that you can read carefully. Again, you want to make sure that this big idea. So let me actually type that real quick for us. Let's go in green again. Again, you want to make sure you're looking at variable means a letter. So if you keep that in mind, you can know to eliminate some of these. So since it says independent dependent variable and it has those values there, meaning those numbers, you know it can't be those, because we're looking for where it has strictly a letter. So let's see. Again, if you find a benefit to replace this with x and y, just like our normal equations that we've been working with, or our normal functions that we've been working with, you can do so. So that means this: if we have our variable x, that means that h is going to be our independent variable. So we know that our independent variable is going to be h, and the dependent variable is going to be c. So we know that it is that third choice. And for the last one on this page, it says select all correct answers. The formula for the volume of a cone, V equals 1/3 times pi r squared times h, where r is the radius of the cone's base and h is the height of the cone. Which of the following are the independent? So we're looking for the independent variables in this one. So that means that the only dependent variable is this. Our only dependent variable is going to be v. So that leaves the other options like this. We would say, we know since 1/3 is a value, pi is a value, that means that r and h are going to be the independent variables in this situation. Again, anytime you're looking for an independent variable, you know it's not a value, and it cannot be the, for this case, we're looking for a dependent, or excuse me, the independent, so it cannot be the volume. On the back, nope. On the back it says number 5, a frequent traveler kept careful records of fuel consumption. The scatter plot below shows the amount of fuel used and the amount of fuel remaining in the gas tank. Based on this model, what is the dependent variable? And so anytime you're working with these, just read carefully, take your time, take a deep breath, relax. You want to make sure you can see what is our dependent variable, meaning what depends on the other. So we're looking for the dependent variable. So let me highlight it like this, and we're looking for that dependent variable. And so usually, again, that's going to be our y values. And so that kind of makes sense too, because our amount used is going to affect the amount remaining. So that means that for this one, we would say the number of gallons of remaining fuel is going to be our dependent variable for that one. And number 6, it says every year on your birthday, one of your relatives gives you $1 for every year of your age. Which is your independent variable? So we're looking for independent variable. Again, the amount of money that you get for your birthday depends on your age. So we would say your age is going to be your independent variable for that one. And in those bottom 3, it says a travel agent provides a discount based upon the amount of money a client spends. The discount program is outlined in the table below. What is the independent variable? So if you notice, again, this is the measured amount, where this is the result of the discount. And so if we're looking for independent variable, we're going to be looking at those x values. Those are usually going to be on on the left there, so you want to make sure you can see that carefully. So we would say the amount of the discount, or excuse me, the amount of, let's back up, the amount of the travel package. Gotta read carefully for that one. Again, make sure you're seeing that it is the amount of the travel package affects the percent of discount, meaning the more you are traveling, the more discount you're going to have. For number 8, it says James has $50 in his lunch account. He will use $3.10 to buy lunch each day. The equation below shows he will calculate the amount remaining in his lunch account, A, after day's lunch, L. Which of the following is the independent variable? So for this, again, you can make sure you're saying, again, A is the amount remaining, so that's going to be our dependent variable. So that's basically going to be Y, and that means that L is going to be X. And since we're looking for specifically our independent variable, and more importantly, a variable in general, we know that we cannot choose these two because those are just numbers, where we could mainly pick L as our independent variable. And lastly, for this page, it says following says the formula of for the surface area SA of a square-based pyramid is surface area is equal to 1/2 times the slant height times the perimeter of the base plus the area of the base. And we'll actually talk about that later, and I will be saying that a lot of the times, where L is the slant height, P is the perimeter of the base. Oh, I didn't even realize I had it there, so good for me. And B, big B, is our area of the base. So what is the dependent variable? Well, again, the surface area of the whole entire pyramid is going to depend on those lengths. So we can say that these variables to the right are independent, where the surface area is going to be dependent. So again, make sure you are just reading carefully for those, so that way you know where you are at.